Hi everyone, welcome once again to my YouTube channel. Today we're going to discuss how you're going to identify and label types of variables in research and statistics. If you've been following my YouTube channel and you're yet to subscribe, I want to encourage you to subscribe. Just hit the red light button below this video and then hit the bell that pops up immediately after the red light button. I want to encourage you that you should be a little bit patient with this tutorial today, as it's going to take us some time to explain some practical aspects of types of variable in research and statistics. So once again, you are welcome. Let's go to the lecture properly. All right, let's know what a variable is before we talk about the types of variable. Although I've discussed this in my previous video on concepts, constructs, and variables. So a variable is a concept or a construct that can be assigned value to. Either you assign it directly or you develop items in order to assign values to those items. So the ones you assign directly can be concepts, but the ones you don't assign directly can be constructs. So a variable is a concept or construct that you can assign values to. Any construct that you are measuring, you need to develop items to them to measure it. That construct itself, which items are being raised to measure, is called latent variable, while the items you are using to measure the latent variable are called observed variables. These are important terminologies in structural equation modeling. Another thing you must know about structural equation modeling is exogenous and endogenous variable. My video on path analysis and structural equation modeling will explain this better for you. So now let's go into the types of variable with practical explanations. All right, the first type of variable we are going to discuss here is the dependent variable, which is designated here with DV. It is sometimes called the outcome variable, or you call it the criterion variable. It is a variable that changes when the independent variable causes it to change. So there is what we call independent variable. So if independent variable acts on DV, which is the dependent variable, it changes. So an independent variable is sometimes called the predictor variable, and it is that factor that is manipulated or causes the DV to change, and that is why we call it the manipulator. It is called the manipulator or the presumed cause, while the dependent variable is called the effect. These two variables are difficult to be avoided in research. In fact, you can't avoid them. You can't avoid them. All other variables are hinged on these two types of variable. There is a connection of all other variables to these two types of variable. So to understand the connection between these two variables, let's look at a practical example of a research title, which you can turn to a research question or hypothesis, as the case may be. Influence of teacher effectiveness on students' academic efficacy. In this example, teacher effectiveness is the IV. Why students' academic efficacy is a DV? Because it is the teacher effectiveness that can be manipulated or is manipulated to see changes, to cause students' academic efficacy to change. All right? So to still demonstrate this more practically, let's look at a model with a diagram, which is we are using a schematic diagram to explain how IV and DV are related. In my future video about conceptual framework, how to design or develop a conceptual framework, we're going to understand this model very well. But for the benefit of this lesson, just begin to get insights on conceptual models. So looking at the model I've just drawn here, we can say something that the IV impacts on the DV, and that is why it is one-headed arrow. In this case, we can say that the dv is regressed on the iv. So this is a simple model that can explain the relationship between iv and dv. So let's look into other types of variable. All right, the next type of variables we'll look at is the active variable. It is sometimes called a type of independent variable, and is a variable that can be manipulated. Using this example we have here, we're saying effects of formal mentoring on teacher effectiveness. Formal mentoring is a variable you can manipulate for teacher effectiveness to change. That means if you give teachers formal mentoring, their effectiveness at work will change, or either increase or decrease as the case may be. That is said to be, so formal mentoring is said to be an active variable because you just manipulate it. Another example you can see here is mind mapping has no significant impact on student practical skills. Mind mapping is the active variable. So any variable, any independent variable that you do not manipulate, but just measure it because it causes change on the dv, that variable is called attribute variables, which we say attribute variable, which is another type of independent variable, is that variable that is not manipulated, but it can only be measured because it causes a change in the dv. Example of such variables are inborn characteristics or our psychological states of mind. Let's look at practical example that will help us to explain that. If we have a title like this, effect of gender on customer satisfaction. So we want to see how gender determine how an individual is satisfied as a customer. Gender here is called the attribute variable. Remember, gender imparts on customer satisfaction, but because gender is not measured, gender is not manipulated but just measured, it is called attribute variable. Another example we can have here is self-esteem significantly determines students' learning outcome. Here, self-esteem is a psychological state of an individual or psychological condition. So remember, we say inborn characteristics, psychological states are aspects of attribute variables. So self-esteem here implies that it is active attribute variable. So let's look at the rest type of types of variable for this lesson. All right, another type of variable that is important here is the moderator variable. It is defined as that variable that alters. In altering, it could strengthen, it could weaken, or reverses the direction of the relationship between the independent variable and the dependent variable. It can be that variable that interacts with the independent variable to have a change on the dependent variable. So that's just the definition. So it's a moderator. It's something that changes how IV and DV are linked. Let's look at some examples. Let's have this research title example: relationship between social media exposure and student engagement, the mediating role of self-control. What this is implying is that social media exposure can affect students' engagement. So social media exposure is the independent variable, while student engagement is the dependent variable. But self-control may be what can strengthen or weakens that relationship between the IV and the DV. Let's understand this explanation using a model. If we have our model here trying to say that we have the IV, whereby the IV imparts on the DV. So we have seen this when we discussed the how dependent and independent variable are related. But whereby there is a moderator, we often use an arrow to link between let's use W here to represent a moderator. So we use an arrow to link that there is a moderator variable acting where there is IV and the DV. So this implies moderation. This is how you can conceptually model moderation. So this is how a relationship between dependent, independent variable and moderator variable can be conceptualized in research and statistics. So let's look at more examples. We have another example of moderator variable. Marital status will not have significant interaction with the effects of mentoring on job performance. What we're simply trying to say here, although this is a null hypothesis stated, that mentoring is the independent variable which impacts on staff job performance as the case may be. But marital status may be that which can strengthen the relationship between mentoring and performance, or weakens that relationship, or reverses it as the case may be. So this is an example of moderator variable. So let's look into the next variable. Another important variable that we'll look at again is the intervening variable, which is sometimes called the mediator variable. In fact, in behavioral research, mediator variable is a very important variable that we cannot neglect too, especially when we are implying that IV leads to DV. So here, it is that variable that explains the relationship, the link, the association between the independent variable and the dependent variable. That means a mediator variable explains how an independent variable is related or associated with the dependent variable, or it answers the question, why does independent variable influences a dependent variable? Let's look at some practical examples. An example we have here is the mediating effect of political will in the relationship between leadership style and performance outcome of politicians. What we're saying here is that political will could be used to explain how a political leadership style has effects on his or her performance outcome. So this is telling you that political will is the mediator or the intervening variable, leadership style is independent variable, and performance outcome is the dependent variable. For the benefit of this lesson, let's model it once again. We have these three variables. One is the DV, one is the IV, and one is the mediator. So mediator is often said to be in between the DV and the IV. So let's consider that this one is our independent variable. So this one is our mediator variable. Let's use M here to represent it. And this is our dependent variable. Now, originally we have the idea that the dependent variable must impact on the independent variable. So we represent it with this arrow. So to model dependent variable, independent variable, and the mediator variable, we follow this approach. You can see the arrows, how it is done here, just for us to have an insight on the conceptual model on how to do this. So this is how you can model the independent variable, dependent variable, and the mediator variable. Right. So let's look at additional examples of the mediator variable. One good example we can talk about here is that teacher effectiveness influences students' academic performance via learning self-efficacy. So this is how you can equally state a hypothesis that has to do with mediator variable. Here we are saying that teacher effectiveness determines students' academic performance, but this relationship can only be explained through self-efficacy of the learning self-efficacy of the students. All right, quickly, let's look at other types of variable. The next one we're going to look at here is the extraneous variable. Extraneous variable is a variable that is not investigated in the study, but it could have effect in the study. That is, it can be related to either the independent variable or the dependent variable. Take note, as said, it can be related to either of them. That means it's not both at a time. It's either related to IV or the DV, but it often affects the DV. It often affects the DV. So that's a variable that you do not measure, but has the tendency to affect the DV, and is either related to the DV or the IV. It's called the extraneous variable. But in research, especially in experimental research, these variables can be controlled. So an extraneous variable is a variable you can control, and you control them using some kind of approaches to avoid invalidity they could cause in research. That is another lecture, another tutorial on this. Now let's look at another type of variable, which is the confounding variable. The confounding variable and the extraneous variable are often confused by beginning researchers. Actually, they are slightly different. There's a thin line between them. So the confounding variable is actually an extraneous variable, but it's that extraneous variable that is related to both the IV and the DV at the same time. It's related to both IV and DV, and it equally affects the DV, which is the dependent variable, and therefore impacts on the result. That means giving you an outcome instead of believing that the outcome is as a result of the independent variable. So when an extraneous variable is related to both IV and DV and then contributes to the result that you have, it is called confounding variable. Because it contributes to the result, it is often said to be confused variable. That's why people call it confused variable, because its effect may be confused or mistaken with the effect of the IV. Before we show the practical demonstration of these two variables, let's also just quickly look at control variable. In research, there's what we call control variable. Control variable is a variable that you leave constant as a researcher, a variable that you presume that it does not change in that study, but you can measure such a variable. However, you do not hypothesize such a variable. Now, let's look at a practical example of how to explain these two types of variable here. A title like this: Effect of COVID-19 Pandemic on Death Rates of Nigerians. COVID-19 pandemic is the independent variable. Death rate of Nigerians is the dependent variable. Now, if we consider age, hunger, loneliness, chronic diseases, weather conditions, poor medical attention, and so on as the possible extraneous variables. Now we can say, let's look at weather. Is it possible that weather has something to do with COVID-19 pandemic, or that weather has something to do with leading to death? Yes, of course, we may say that weather has something to do with leading to death. You know, if you have a very harsh weather, it may lead to something else, and which can lead to death. Then we may not be outrightly correct to say that weather has something to do with COVID-19. In this case, this weather can be controlled if we must take this study between COVID-19 pandemic and death. So weather becomes the extraneous variable. But let's look at age, for instance. Does age have anything to do with COVID-19 pandemic? Of course, we can say yes. Why? Because even scientists have proven that COVID-19 has a relationship with age. And that is why during COVID-19 pandemic, it is said that either very older people are easily affected with the pandemic also. So you can see the issue of age here. And at the same time, we can say as one gets older, we're expected to experience death. So if the death rate of Nigerians, that is the older people in Nigerian death rate, is so high, we can say that age is related to COVID-19, and age is related to death rate, and also related to the death rate of being old, as the case may be. Then age is said to be the confounding variable here, because we're now confused. Is it COVID-19 that led to the death rate of older people in Nigeria, or is it as a result of their age? Once again, age here becomes the confounding variable. Right, because of the importance of measurement of variables, let's classify other variables into different categories of variables. Now, the first one we're going to discuss here is the qualitative variable. They are said to be non-numerical variables. That means that their values are just assigned to them, but not as a result of measurement. There are two types of qualitative variable. The first one here is the nominal variables. Nominal variables are sometimes called the categorical variable. You just use value to just categorize the variable, which means that there is a variable that assumes number just for the benefit of identification. Let's take gender, for instance, which has two values, male and female. If a male is assigned 1 and the female is assigned 2, 2 does not mean that a female is bigger than what? Male. So it's simply for a mere identification. Such a variable is called nominal variable and is classified under qualitative variable. Let's look at another type of qualitative variable, which is the ordinal variable. The ordinal variable is a variable that the possible values are ordered. That is, they can be said to be in the highest to the lowest value or lowest to the highest value. Take academic qualification as an example. Academic qualification, that is, let's say your bachelor degree, master's, and doctorate. PhD can be said to be higher than master's, and master's can be said to be higher than bachelor degree. So class of degree like first class, second class, upper division, and second class, lower division, and third class can be said to be ordinal variable. Scale of industry such as micro scale industry, medium, large, small, as the case may be. These are examples of qualitative variables in nominal and ordinal forms. Having discussed the qualitative variable, let's look at the quantitative variable. These are variables that numerical values are assigned to them as a result of measurement. That means you either measure them using scales or questionnaire, as the case may be, but there must be something you use to measure such a variable. Let's look at the two types of quantitative variable. The first one I have here is the discrete variable. These are variables that assume countable values. So the measurements we are talking about here is either by counting a number or by using scales to measure. So discrete variables are the ones that assume countable values. That means they have finite sets of values, which are often whole numbers. If you say number of students in a class, you can count it to be 20, 30, 33, 45, 5,000, as the case may be. But you can't count it as 32.5. No. Why? Because that number is not finite. 32.5 is not a finite number. So any variable that is measured as finite in that form is called discrete variable. Now let's look at the second type of quantitative variable, which is called the continuous variable. A continuous variable assumes measurable amounts of values, which means it may take the form of fractions or mere approximation. Let's take, for instance, when we say weight, an individual weighs 68, for instance, doesn't mean that 68 is an absolute value. It simply means that it took an approximation. So it could be 68.2, 0.3, as the case may be. Other examples are here. So these are the two types of quantitative variable, the discrete variable and a continuous variable. All right, so far we have discussed all the types of variables that are necessary for us to understand research better. So there is a puzzle for you. I would like to conclude this lesson by presenting a puzzle for you. And the puzzle is simply that you can formulate 3 titles in your field of study, your area of specialization, identify all the variables stated here, right? The EV stands for, EV here stands for extraneous variable. This is called confounding variable, and this is called control variable. Remember, this is moderator variable, dependent variable, independent variable, and then this is mediator variable. So identify them. Also state 3 hypotheses in order to do that. All right, before I end this lesson, I really want to say, if you've not subscribed to my channel yet, please subscribe. And when you subscribe, share my video. If you like, make comments that you like it, and then comment on it. Let's keep this tutorial, this YouTube tutorial active, and continue watching my video. When I come next with my tutorial, once again, we'll meet in the next lesson.